was working a job once where we were adding a BMS, or Building Management System, which is kind of like a SCADA. If you don't know what that is, don't worry, we'll get to it in a later date. We were adding a BMS to an existing building. There was a new piece of equipment that we were adding to a legacy piece that we were not going to remove, and it did not have a new controller to go with it. The customer did not want us to change out the existing controller because the piece in question actually worked. And so the question came up, well, could we run it off of the BMS? And I thought about it, and it was something simple, like a fan or something. I don't quite remember, but yes, the solution is technically feasible. But I have to ask, why don't we just change the existing local controller? This is the piece of equipment that's going to want it to run anyway. To which the answer was, well, the customer is too scared to change it themselves, and it's out of scope for us, and we don't want to take the liability for it. Which I understand, but now we have a situation where because somebody is scared or because we didn't take the time to look over the entire job, we now have a piece of equipment that even still today sits out in the field, and it's technically functional, and yet it's dumb all the same. Hello everyone, and welcome to Chaos and Controls, the show where we talk about modern devices, technology, and techniques to automate your home, business, or life. I'm your host, the Automation Doctor. Today, I thought we could talk about something like the topology of how most modern automation systems look like. I'm going to show you a technique that I like to use myself that you won't necessarily see in any textbook anywhere. But it's a technique that I myself use nonetheless, and so without further ado, let's go ahead and talk about the hierarchy of controls in a conveniently located triangle, like this one. Now again, this is by no means an all-encompassing graph that I'm trying to show you. It's just a tool that I use myself out in the field, and you'll notice that I've got everything broken down into really only 3 different groups. At the top of the triangle, we have the overall system manager. This is where things like your SCADA system, which stands for Supervisory Control and Data Acquisition. In our opening story, that would be the BMS system that we were adding. It really helps to give you a 50,000 foot level of how a system or a group of systems are interacting. This is also something that is notably absent in most houses, and why things like your Google Home comes in and is able to link all the systems, and everybody likes that because it's really somewhat of an unexplored niche that the industry at large has had for quite some time, but it's just now starting to make its way into proper home automation, and where I really anticipate we're going to have some opportunities to talk about it in the future on this channel with regards to the home. Now, the next layer down is going to start getting a little bit muddled, but you'll see here that I've got it marked as your local controllers. But local controllers can really have a wide breadth, and in my mind they can be as simple as something like a light switch in your house. That is also going to be a field device that we'll talk about here in a moment, but it is the control mechanism for the light, so therefore it is the local controller, all the way through something as complicated as a PLC, programmable logic controller, or even an industrial PC that may be making thousands and thousands and millions of computations a second to try and figure out what an appropriate method for doing whatever. Maybe we're moving product, maybe we're turning lights on, maybe we're analyzing data. Could be all sorts of things, but to make the local decision for how hardware and devices in the field are actually going to act. And that really leads us into our final category, which is your field devices. And again, this could be all sorts of stuff, ranging from a light switch that is both your local controller, because it is what ultimately controls electricity going to your lights or your fans or your whatever, but it's also a field device because it's taking an input from whether or not the local user wants those devices to be on. Field devices come in a couple of different flavors. You have inputs and outputs. A light switch would be an input and an output because it's taking what the user wants to do, making a decision. In this case, it's a dumb decision because it's just doing exactly what the user just did, and then sending power to that device. But if I was to take that same light switch and then run its output to, say, a programmable logic controller, and then I would use the controller to read whether or not the switch is on, and then use that to make the decision for whether or not to turn on my fan or my light, it would then be just an input. We'll get into more examples of this at a later date. It's also worth noting, however, that inputs and outputs really come also in their own two different kinds of flavors. We have discrete devices and analog devices. Now, when I say discrete, another way to say that is binary or Boolean, or it is simply a device that can be on or off. It has two states, and that's it, on or off. A light switch is another example of a discrete device. It is yes or no. Analog devices, on the other hand, have a wide breadth of values that they can take. A common example of this you might see is a temperature sensor, which doesn't tell you temperature yes or no. It tells you that the temperature is 74 degrees or 68 or 85. Whatever the case may be, it's got a range of values that it can take on. This would be an analog input device. An analog output device might be something like a motor that you want to run at different speeds. I don't just turn the motor on yes or no, I tell it turn on and I want you to run at 17 hertz, at 60 hertz, at 120 miles an hour, whatever the case may be, it's an analog output. All of these inputs and outputs then come together back to the local controller so that it might make the best decision for the variables at hand and then report that situation back up to the SCADA system so that we can notify users of how the plant or the building or the series of buildings are performing. And so anytime I'm out in the field and trying to get a rough idea for what's going on and how the system's set up, I have a tendency to use this triangle to try and, if I were building the system, how would I have it report out? And I found it to be a pretty good guiding star. In any case, that's about all I have for you today. Everyone, have a good one. We'll catch you next time.